Hello friends, welcome to the session on the microprocessor 8085. In this session, we'll be discussing about IC 8255. In this session, we will see what we mean by IC 8255 and how this IC can be used in interfacing applications. Friends, as you know that you are viewing this session on my YouTube channel, and do subscribe to the channel to see many other videos on the various topics of the subjects of electronics and computer science. So let us start the session with the question, what we mean by IC 8255 or 8255. IC 8255 is being called as a PPI or Programmable Peripheral Interface. This IC was developed and manufactured by the Intel organization. So as shown in this photo, you can observe that this IC 8255 is a 40-pin IC. So this IC is being used for interfacing applications. So whenever you want to interface any external devices with the microprocessor 8085, then you need this IC. This IC will provide 24 parallel input-output lines, and these input-output lines can be controlled through the programs. So they have a variety of programmable operating modes. It is a 40-pin IC, and this IC can be used with the microprocessors such as 8085 and 8086. This IC will give the CPU or digital system an access to the programmable I/O. That is, whenever we want to interface some external devices such as switch, LED, or 7-segment display, then such interfacing is possible through the IC 8255. This IC is being widely used in the digital processing systems such as microcomputers, or whenever we think of any IBM PC, then one can find that this IC is being used in the IBM PC. By using this IC, as I told you, we can interface the devices such as light emitting diodes or switches or LED display devices to the microprocessor 8085. 8085 can transfer the data between the external devices, and this transfer of the data will take place through the ports that are available with the IC 8255, and these ports are being called as the IO ports or input-output ports. There are 3 ports, and every port has 8 pins, and therefore we can say that there are 24 pins that are being available with the IC 8255, and these pins can be attached with the several IO devices. And whenever we attach the several IO devices, then their control or their function can be controlled by using the control word in the IC 8255. So as I told you, there are 3 ports, and each port is of 8 bits or 8 lines, and therefore there are 24 pins available to which we can connect the external devices. So this is a block diagram for this IC 8255. So one can easily observe in the block diagram that this is a port A, and there are 8 pins available, bidirectional pins available for the port A. Similarly, we have a port B, and there are 8 bidirectional pins available for the port B. Port C is being divided into 2 parts, upper part and lower part, where we have 4 lines for the upper part and 4 bidirectional lines for the lower part. So there are 3 ports, and these ports are being named as A, B, and C ports. Port C is being divided into 2 groups, upper group and lower group, and there are 4 bits for the upper group and 4 bits for the lower group. Also, we have a data bus buffer. So this is a 8-bit bidirectional buffer, and this bidirectional buffer is being used to interface 8255 to the system data bus. Data is being transmitted or it can be received upon the execution of the input or output instruction by the central processing unit or by the microprocessor. Also, we have a read-write control logic in this IC, and this block is being used to manage all transfers of both data and control word. It will accept the input from the CPU and it will issue the commands. So this is an important block of the IC 8255. Also, one can easily observe that there is a chip select. It is an active low input, and this will enable the communication between the IC 8255 and the microprocessor to which it is connected. So this is an active low input and it must be activated in order to have a communication between the IC 8255 and the microprocessor. Also, we have a read enable input, and this is also an active low input, which will enable 8255 to send the data to the CPU or microprocessor. Also, we have a write enable, and this is also a active low input, which will enable the CPU to write the data or to send the data to the IC 8255. Apart from that, we have the two pins A0 and A1, and these pins are being used for the port selection. When A1 and A0 is equal to 00, then port A is selected. For 01, port B is selected. For 10, port C is selected. And for 11, the control word is being selected. Also, we have a reset pin, and this reset pin, a high on the reset pin, will initialize the control register to 9B hexadecimal. And all the ports A, B, and C are being set to the input mode. So we have two kind of control, group A control and group B control, as shown in this block diagram. So these group A and group B control accept the commands from the read-write control logic. It will receive the control word from the internal data bus, and it will issue the proper commands to the associated ports. So we need to write an appropriate control word so that we can get performed the particular port as an either input port or as an output port. So these are the pins that are being available with this IC. This is a 40-pin IC, and one can easily observe that out of this 40-pin IC, 24 pins are being used for the ports. So we have 8 pins for the port A, 8 pins for the port C, and 8 pins for the port B. Also, one can easily observe that this IC will require a VCC of +5 volt and a ground voltage of 0 volt. There are data lines from D0 to D7 as shown in this diagram. It has reset, A1 is 0, read-write control inputs, and also the chip select input. So these are the pins that are being available with this IC 8255. So the control word of 8255 plays very important role in the operation of 8255. The content of the control word are control register are being called as a control word, and this control word will specify the input or output function for the each port. The control word register can be accessed to write the control word by selecting A1 and A0 in the high condition, that is both on. This register is not available for the read operation, so it is internally used. As shown in this diagram, one can easily observe that this is a 8-bit word, out of which the bit D7 is being used for selecting of the mode. That is, we can use either this IC in the bit set reset mode or in IO mode. The next two bits are for the mode selection. Then we can decide the port A to be used as an input or output port, port C upper part to be used as an input or output port. Then we can decide about the port B selection as an input or output, and similarly the port C, lower part of the port C, as an input or output port. The most significant bit, D7 of the control word, will specify either the IO mode or the another mode that is being available with this IC is the bit set reset mode. Now, whenever we want to communicate with the peripheral through the ports of the 8255, then we need to follow certain steps. And these steps are like this. Initially, we need to determine the address of the ports A, B, C, and of the control register according to the chip select logic and the address lines A0 and A1. Then we need to write the appropriate control word into the control register so that we can use the specific ports either as an input port or as an output port. Then we need to write the input output instructions in order to communicate with the peripherals through the ports A, B, and C of the IC 8255. Now let us understand about the operating modes of the IC 8255. There are two modes that are being available with the IC 8255. The first mode is being called as the bit set reset mode. And this mode is being used only for the port C. So whenever you keep this D7 bit equal to 0, then this is just nothing but the bit set reset mode. The bit set reset mode and IO mode are independent, and the selection of the bit set reset mode does not affect on the operation of the other ports in the IO mode. So one can always make the use of this bit D7 as equal to 1 whenever you want to make the use of IO mode. There are three different IO modes possible: mode 0, mode 1, and mode 2. In the mode 0, we can say that these are the simple IO modes for all the ports A, B, and C. Mode 1 is being called as a handshake IO mode for the port A and or port B, and port C bits are used for the handshake mode. In the mode 2, the bidirectional data bus for the port A, port B either in mode 0 or 1, and port C bits are used in the handshake mode. So this is a control register for the bit set reset mode, where you will find that this bit is being always kept equal to 0. And this X will indicate that we need not to care about D6, D5, and D4. And these bits, these are the port C bits that we can set as per the requirement. And this bit we need to set, or we can make it reset. So whenever you think of the bits B2, B1, and B0, then they will be used for the selection of the pin of the port C. If it is 000, then PC0 pin will be selected. For 001, PC1 pin will be selected. 010, PC2 pin will be selected. And in this way, 111 will get selected the pin PC7. As I told you, in IO mode, there are three IO modes, such as mode 0, mode 1, and mode 2. Now we will understand some example through which we will understand how this control word can be set. Say, for example, if port A and port C are to be initialized as the input ports, and port B is being used as an output port, and suppose we want to use mode 0 for all the ports, then in that case, we can set this control word like this. Since it is an IO mode, the bit D7 will be set to 1. Then the mode selection bits such as D2, D5, D6 will be all 0 for the mode 0 operation. Then bit D4 will be equal to 1 because we want to use port A as an input port. Then D3 and as well as D0, both of them we keep as 1 because we want the port C as an input port. Now suppose we want to use port B as an output port, and therefore this bit D1 is to be kept as a 0. And therefore you will find that this control word will become 1001 1001. So this is just nothing but 99 hexadecimal. That is, whenever you want to use port A and C as the input port and port B as an output port, then in that case you need to set the control word as 99 hexadecimal for this IC 8255. IC 8255 is a very useful IC, as I told you, and through this IC we can interface many IO devices such as light emitting diodes, switches, or LED display devices to the microprocessor 8085. And whenever we connect such external devices to the microprocessor 8085, then that is being called as a interfacing. It is possible that we can put the LEDs connected to the ports on and off through the assembly language program. We need to write an appropriate assembly language program. As shown in this diagram, we can connect the light emitting devices or LEDs, or we can connect the external switches to the different ports of the IC 8255. And this IC can be further connected to the microprocessor 8085. It is also possible that we can read the switch position, or we can generate the square wave at a specific port by writing an assembly language program. We can interface DC motors. Also, we can interface the 7-segment display for the IC 8255. Now, suppose this is a sample program, assembly level program that is being written to make the LED on and off. And suppose the LEDs are connected to the port B. Now, initially, we have designed the control word, and since we want to use port A and C as input port and port B as an output port, our control word will be 99. So initially, we will make this control word 99 to be moved into the accumulator by using the instruction MVIA, CW, or directly you can write 3E99. Then we need to out this word to the control register, and you must know what is the address of the control register. Suppose in our case, the address is 43 hexadecimal, and therefore we can make the use of the instruction out 43. Next, we want to make the LEDs, alternate LEDs on and off, and therefore we will use the binary data such as 01010101, and therefore the hexadecimal number 55 will be moved into the accumulator, and this number will be made available at the output port B by making the use of the instruction out 41H. So here we must remember that 41 is the address of our port B. So once you out this number, then you will find that the LEDs that are being connected to the 8 lines of port B alternately will be on and off. And finally, we can halt the program. So you can type this program, and for this you need to interface LED to the port B. And when you execute this program, then you will find that the LEDs that are connected to the port B alternately, they will be on and off. So thank you, friends, for viewing the session. Hopefully you have understood this IC 8255 and the working associated with this IC 8255. Thank you all for viewing the session.